Okay, today we're going to talk about adding and subtracting rational expressions. And again, rational expressions are expressions that are ratios or, fractions, we might think about them. So let's just do a quick review of adding fractions. If I had 3/5 plus 4/5, hopefully everybody remembers that when you add fractions, if they have the same denominators, then you simply add the tops together. This is 7/5. So this is like having 3/5 of a pizza and 4/5 of a pizza. So altogether you'd have 7/5 of a pizza, right? Seven pieces of something cut into fives. So very simple, right? If you had something like 3/5 plus 4/3, however, that's a different story. They are different sized units. So what you have to do is you have to make them the same size units. So you're going to cut these into, these fifths into 3 pieces and these thirds into 5 pieces. In other words, you're going to cut them all into 15ths to make it easier to divvy out, right? So how do you do that? You find your common denominator. And your common denominator here is going to be 15 because that's the number that both 3 and 5 divide evenly into. So this first one I'm going to multiply, the second one I guess, I'm going to multiply by 5/5, which is simply just 1. So I'm really not changing the fraction. And why did I choose 5? Because that's going to give me the 15 that I want on the bottom. And on the top will be 20. We'll have a 15 on the bottom and 9. So this will be 29/15. So now it makes it easier to break the pieces because now you've converted these both fractions into something they're the same size. Right, so it's 29/15. And you'd have to do the same thing for subtraction. You'd have to find your common denominator. And of course, if you had 3/5 plus 2/10, for instance, then if the common denominator, what these both divide into evenly, is already one of the one of the denominators, then you really only have to change one of them. So this one I would change to tenths. So we would say 10. And this one would be 5/10, which of course you could reduce or whatever, but not important to this conversation. So finding a common denominator is really the basic idea for adding and subtracting these rational expressions. Now we did them with numbers, we're going to do them with expressions that have variables in them. So if I have 3x minus 4 over x plus 2 plus 5x minus 7 over x plus 2, well, we have two fractions with the same denominator, so all we have to do is add the tops together. So the numerators, in other words. So this is going to be 3x minus 4 plus 5x minus 7 all over x plus 2. And of course, then we combine our like terms. What's the 3 and the 5 when we combine them? If I have 3x's and 5x's, I have 8x's altogether. A -4 and a -7 is going to give me a -11 over x plus 2. And the last thing you should do is just see if there's any way you could reduce the fraction. So just like this one, I would reduce it to a half. If this were reducible, we'd reduce it, right? And what's the difference if it's subtraction? Really nothing. This time it's 3x minus 4 minus 5x minus 7, since they have the same denominator. So it's going to be 3 minus 5, so that would be -2x. -4 minus -7, so that's actually going to be 4 plus 7, so that's going to be a 3. And again, my last step would be to find the common denominator. I mean, not find the common denominator, reduce if possible. So again, they might ask you to name the excluded values. They don't always ask you to do that. Or they might say find the x values for which the expression is undefined. In that case, in both of these, x cannot equal -2, right? And how did I know that? Because the -2 is what's going to make these denominators come out to be a 0, right? So you should always probably list that when possible anyway, okay? Even if they don't really ask you, it's always nice to put it. Okay, so here's one more. Let's do this one. Let's try x squared plus 3x plus 2 maybe. And let's take these ones. Okay. Now these denominators are not alike, so we can't just add them together. So the first thing I'm going to do is figure out what factors are in each of these denominators. And why do I want to do that? I can see this one only has one factor, so I know that's that. I want to do that because just like this one, I want to keep the denominator as small as possible. In this one, I had to multiply both of the fractions by something because these numbers were relatively prime, we say, right? They don't have any factors in common, so their least common multiple is going to be those two numbers multiplied together. But here they had factors in common, so I only multiplied this one by 2 instead of multiplying this one by 10 and this one by 5 and then having to reduce a big number at the end. I'm doing the same thing here. I'm going to find out if this has a factor of x plus 1, because if it does, I'm not going to multiply this one by x plus 1. Okay, so let's take a look. It has to be a 2 and a 1, an x and an x. I need a 3, so that means these are both plus. And now we see that they share the x plus 1. So we know when we find our common denominator, we already have an x plus 1. That takes care of this one and this one. And now I'm going to need an x plus 2 in the denominator also, right? Because you need to represent all of the factors. So this is the guy that does not have an x plus 2. So what do we have to do? We have to multiply this one by x plus 2 over x plus 2. All right, so over here, this is going to be, I should have left a little more space, but I'll put it down here. It's going to be x squared plus 2x. Right? That's what happens when you multiply this out. And this one, I'm not going to multiply by anything because he already has the x plus 1 and the x plus 2. So you can see how this one's going to be an x plus 1, x plus 2 on the bottom. So now they both have this common denominator. And this one, I'm going to, leave as x minus 1. Now I'm going to combine my like terms. What terms are alike? Well, there's only one that's an x squared, so it's this guy. He stands alone. There's these two x terms, so that will be plus 3x. And then there's this one that's a constant. And now we've combined our like terms. We're good. How wonderful was that? Don't even have to multiply out that denominator. I wouldn't bother with that. It'd be a total waste of your time. Okay, let's do one more, and then basically you have everything you need to know. Let's try this one. Okay, so I put in our fancy difference of squares here a little bit. Okay, so the first thing I'm going to do is factor out what they have in common on the top. So, and I'm only going to do that just to see if there's anything I can cancel right away. But I don't think there is, so I might not even need to factor that at all. But all right, now this guy I'm going to factor. Remember, he's a difference of squares. So I'm going to factor him as x plus 2 and x minus 2. Now you can see that our x plus 2's are the same, right? So that means that this is the one that's missing something because our common denominator is just going to be all of these factors lined up together. So these guys share an x plus 2, so that takes care of this guy. And then the one that's left is x minus 2. And so I just put them here. So that means this guy has to be multiplied by x minus 2 over x minus 2. Okay, now I'm going to put him back as the other way because we're going to try to subtract these things. So this didn't help me at all. It wasn't something I could factor and cancel out or anything. So I'm just going to go back to this one because this way looks nicer to me for what we're trying to do, right? We're trying to subtract them. So we're going to be looking for like terms. I'm going to open my parentheses because this is a minus sign. If I don't put this stuff in parentheses, I'm going to get the wrong answer. And then I'm going to FOIL out this thing. So it's going to be x squared plus 4x minus 2x, so that's going to be plus 6x. No, sorry, plus 2x. Plus 4 minus 2. I just said with my own mouth and then wrote the wrong thing. Minus 8. Okay? And now from here, I'm going to combine my like terms. So 2x minus, don't forget about this guy, right? Minus, let's distribute it. That way I won't make a mistake. Especially when I'm talking, I make lots of mistakes. So I'm going to write that so I don't make mistakes. So I just distributed the negative first. All right, now this one minus this one will give me x squared. So I took care of those. Now I have this guy. There's no other x's. So, and then these two, when I combine those, what's that? A negative 8 over x plus 2, x minus 2. And again, what are my excluded values? Well, what would make this thing a 0? X cannot equal 2, well, 2 or negative 2. So x cannot equal plus or minus 2. There it is. How do you think? Now, the last thing I'm going to do with this one, actually, you know what? Let me just see. Does this factor 4 and 2? I think it does, doesn't it? Does that work out? So that's a plus 2, a minus 4, and that will give me a negative 8. All right, so this one actually reduces. You ready? So I factored the top and the bottom. These will cancel out. And in reduced form, this is actually going to be x minus 4, x minus 2. And this is still true, though, because it's our original thing. So that's still true. So if they ask you to add or subtract, technically this is the right answer. But if they say simplify, then you do have to do that. I don't think anybody could argue that this is simplified, okay? So you might be able to argue with your teacher that if they just asked you to add and subtract, that this is not the wrong answer, but it's always good to reduce if possible, okay? And definitely if the directions say simplify in any way like that, then definitely you must reduce. Okay. Good luck. Try them out.